All right, welcome to practice test number 3 in the official College Board SAT Blue Book. All right, so if you are here for the first time, just note that we have videos for practice tests 1 and 2. It's available on the Allen Mentoring channel. Today, what we usually do is run through about 2 hours. Usually comes out to be about an hour 45, and basically see as far as we can go. I think I'm going to start changing the style to basically divide the videos by test. So by the end of this video, I'm going to finish section 3, which is the no calculator portion, and that'll probably be it for tonight. And then if you come back on Sunday evening at 7 p.m. Eastern, I'll be running through section 4, which is the calculator portion. So although it says 25 minutes max, as I explain it, it'll probably be closer to, I would say, maybe an hour. But we'll see how long it takes. So today, if you follow along, you can actually also go to the description and have a link and click the link to the College Board official free practice tests. They have the PDFs of all of the practice tests in their Blue Book. So it's pretty cool. You don't actually have to spend money on it unless you want the hard copy. All right, so I'm working through practice test 3, the no calculator section. So let's get started. Number 1, a painter will paint N walls with the same size and shape in a building using a specific brand of paint. The painter's fee can be calculated by the expression NKLH, where N is the number of walls, K is a constant with units of dollars per square foot, L is the length of each wall in feet, and H is the height of each wall in feet. Okay. If the customer asks the painter to use a more expensive brand of paint, which of the factors in the expression would change? Well, the only one that really deals with money would be, I see here, K, right? K is a constant with units of dollars per square foot. Everything else has to do with how many walls there are and length and width. So I think K in this case will be the only one that matters if you have a more expensive paint. All right, pretty good so far. Number 2, if 3R is equal to 18, what is the value of 6R plus 3? Well, 3R is 18, we know that. If you double 3R, that becomes 6R, and 6R would be equal to 36, right? Double of 18. So what is going to be 6R plus 3? Well, 6R plus 3 will be equal to 36 plus 3, which is D, 39. So you see here, you don't actually have to solve for R if they're not asking you, what does R equal to? Sometimes all you have to do is change around what they already gave you to get what they want. All right, and you'll see more examples of that probably later in this exam. All right, number 3. Which of the following is equal to A to the 2/3 for all values of A? Well, this is actually asked, I believe, in the first or second stream. Somebody asked, how do you deal with fractional exponents? And maybe that person was referring to this specific problem, because I think it was actually asked A to the 2/3. But if you don't want to go back to the video, I'll quickly explain that with fractional exponents, the numerator is treated like a regular exponent, all right? Just like you treat any other exponent, right? So A to the 2/3, that 2 means that it's A squared, right? It's a regular exponent. The denominator, however, shows you what root you're referring to, right? So when you have a regular exponent, let's say, or a regular square root, say the square root of 16, you're asked, okay, what times itself gets you to 16, right? That's what a regular square root is. And the answer to that would be 4, right? 4 times itself is 16. But what they don't write in this area right here is that we're actually looking for the second root, right? The second root is the same thing as the square root. So this is the same thing right here, okay? And when we write regular square roots, we just leave that kind of blank. It's invisible, right? So when I say, let's say 8, and I take the third root of that, the third root of that would be what times itself again, right? What times itself again gets you to 8. And so we know that the third root of 8 is 2, right? Because 2 times 2 times 2 is 8. So this denominator here basically tells you what is the root, right? It could be a 4, it could be a 5, whatever that nth root is. And so in our case, it's the third root, okay? Also known as the cubic root. And so in that case, D is our correct answer here. If you have any questions or you're confused about fractional exponents, let me know in the chat or in the comments, and if there's enough demand, maybe I'll make a separate video for that. Okay. Number 4, the number of states that joined the United States between 1776 and 1849 is twice the number of states that joined between 1850 and 1900. If 30 states joined between 1776 and 1849, and X states joined between 1850 and 1900, which of the following equations is true? So you could deal with this two ways. The first way is just kind of mentally thinking about X and how you would manipulate X. And if you do it that way, you could run into some trouble. You might mess up and think, wait, is it supposed to be 2x? Is it supposed to be x over 2? Right? And that kind of maybe messes with your mind a little bit. What I like to do with these types of problems is actually set a value for x and then check it against each of these 4 choices. So what do I mean by that? Well, we know that between 1776 and 1849, 30 states joined between these years. Okay, and we know that half that much joined between 1850 and 1900. So x, in that case, would be 15. Right, following along so far? So if we know that x is 15, we can check this value against all of these equations and see which one it's true for. All right, so here, 30 times 15 is definitely not equal to 2. 2 times 15 is equal to 30, okay? So don't just stop here and choose it. You want to make sure that it doesn't work for the other 2 choices. Sometimes choosing a variable can work for multiple choices, so we want to be careful here. 15 over 2 does not equal to 30, so that's out. And 15 plus 30 is not equal to 2. Right? And so now we can be 100% sure that B is the correct answer without doubting ourselves. It's supposed to be x over 2, x times 2, right? Choose a value for x and try it out. All right, number 5. If 5 over x is equal to x plus 20, what is the value of x over 5? Alrighty, so in this case, we could just solve for x and see what we get. So how do you solve fractional algebra problems? Well, my favorite method, as I'm sure you've learned, is called cross multiplication. Okay, and cross multiplication means that you multiply the diagonal of one and set it equal to the diagonal of the other. So my first diagonal here is 15 times x, which is also known as 15x. And we set that equal to 5 times x plus 20. And this is true for any 2 fractions that are equal to each other. Any 2 fractions will have this relationship here. So now let's just solve for x. The first thing we want to do is distribute the 5. So we get 5x plus 100. Set that equal to 15x. All right, and then you want to do the opposite to both sides, right? So we want to get the x's all on one side and have the number on the other. So what's the opposite of adding 5x? Subtracting 5x. Very nice. On both sides, this cancels out, and we get 10x is equal to 100. And so now what's the opposite of multiplying by 10? Dividing by 10. All right, we're starting to get this. All right, and so we divide by 10 on both sides. This cancels out, and x is equal to 10. Right, so right away you're gonna be like, oh yeah, x is equal to 10, bam. Nope. We see that they're asking, what is x over 5? So what is x over 5? What is 10 over 5? That's just equal to 10 divided by 5, which is 2. All right, so don't go too fast. Make sure, especially for these early problems, the quote-unquote easy problems, right? Because in the SATs, the math problems get harder and harder as you go along. Make sure that you don't go too fast. You want to get these easy points and ensure that you have the correct answer, right? You would rather mess up on the hard ones that you might not know rather than the easy ones because you went too fast. Okay, so slow down the easy ones. All right, number 6. If xy is a solution to the system of equations above, what is the value of x minus y? All right, so system of equations are solved in two main ways, at least the ways I'm most familiar with. One is elimination, and the second is substitution. Now, I might make a video for system of equations separately, but in this case, I think elimination will work best. Okay, and how does elimination work? You want one of these variables to cancel each other out. All right, and cancel each other out by adding the two equations. So what do I mean by that? Well, I see I have 2x here and 3x here. All right, how would I get these two to cancel each other out? Well, if I multiply this top equation here by -3, and I multiply the bottom equation by 2, I'll see that in this top equation I'll have -6x, and in the bottom I'll have +6x. And if you add up -6x plus +6x, those will cancel out, okay? And when I multiply by -3, I have to multiply by everything in this top equation. So what do I get? I get -6x plus 9y is equal to +42, I believe, okay? And in the bottom, I get, again, I'm distributing this 2 times everything in the bottom equation. So I get 6x minus 4y is equal to -12. So now that you set up your equations so that you will eliminate one of the variables, you can just add these guys up kind of like a sandwich, right? Just add up all three terms. And so here I get 0. Okay, I successfully eliminated the x. In the y's, I will get +5y. And then after the equal sign, I will get 30. 42 minus 12 is 30. And so now I have 5y is equal to 30. So y, it's a bad y must be equal to 6. All right, but they're asking me for what is the value of x minus y. So now I have to solve for x. How can I solve for x? I can just plug in y in either of these two equations, okay, and it should work out. So I'm going to plug in y into, let me plug it into the second equation here. So 3x minus 2, and now I'm replacing y with 6 is equal to -6. 3x minus 12 is equal to -6. I'm going to add 12 to both sides because I want to do the opposite to both sides. And now this cancels out, and I get 3x is equal to 6. Divide both sides by 3. This cancels out. Hence, x is equal to 2. And if x is 2 and y is 6, what is 2 minus 6? -4. Very nice. All right, the function f is defined by a polynomial. Some values of x and f of x are shown in the table above. Which of the following must be a factor of f of x? So these problems come up a lot, and there's, I think, one little math hint that you need to feel pretty confident with these functions and factors of functions. And know this: if x minus b is a factor of any function f of x, okay? So if x minus b is a factor of f of x, then, okay, f of b must be equal to 0, all right? And so if you want to put that on a flashcard, that might help you in the future, but knowing this can help you solve probably like 80% of these types of questions. So if x minus b is a factor of f of x, f of b must be 0. So in our case, we know that f of 4 is equal to 0, right? If x is 4, then f of x is 0. Hence, we know that x minus 4 must be a factor of f of x, okay? And if this confuses you a bit, please let me know in the comments or in the chat, and I can maybe elaborate. But I would suggest writing this onto a flashcard of some sort and add it to your list. Okay, moving on. Number 8. The line y equals kx plus 4 where k is a constant, is graphed in the xy plane. If the line contains the point CD, where c is not equal to 0 and d is not equal to 0, what is the slope of the line in terms of c and d? Okay, very nice. So basically, all they're saying is that CD is the point on a line, right? And we know that XY is also a point on a line. So we can pretty much translate CD and replace it with XY. Okay, so if I rewrite this equation, we could just say that D is equal to KC plus 4, right? All they're saying is that CD is basically like our XY. So now all we have to do is solve for K. So how do you solve for K in this case? You want to isolate K first, okay, if it's attached to anything, like it's attached to KC or it's attached to C, you want to isolate that first, and then you want to isolate just K by itself. So the first thing is we want to subtract 4 on both sides, all right? 4 minus 4 cancels out, and so we get D minus 4 is equal to KC. And then how do we isolate K? We divide C on both sides, okay? Because C is multiplying K, so the opposite of multiplying C is dividing C. And so we see that D minus 4 over C is the correct answer here. Very, very nice. Alrighty. In the system of equations above, K is a constant and X and Y are variables. For what value of K will the system of equations have no solution? Will it have no solution? So in which cases do lines have no solution? Right, because if you draw any two lines, let's say, right, we have a graph. Let me pull this out a little bit. Let's say we have a graph as such. Okay, how do you get two lines that have no solution? Wait a minute, I need my little guy back here. All right, so if you have any two lines, like one like this and one like this, clearly the solution to these two lines is right where they intersect. Right, so logically thinking, how can you have two lines that have no solution? Well, the answer to that is two parallel lines, right? And these are the worst two parallel lines ever drawn, but ignore that. Imagine they're perfectly parallel. We see that these two parallel lines have no intersecting points whatsoever, right? So we know that these two lines are parallel. Okay, so now how do we find out for what value of K will the system of equations have no solution? What we can do is we can rewrite these equations into y equals mx plus b form and then set the slopes equal to each other, right? Because we know that the slopes of two parallel lines are exactly equal. Okay, so let us rewrite these in y equals mx plus b form. So this top one here, I'm going to add 3y to both sides. Okay, plus 3y. I'm going to get 3y is equal to, 3y plus 4 is equal to kx. And then 3y, I'm going to subtract 4 on both sides. This cancels out. So 3y is equal to kx minus 4. And lastly, I want to isolate just y. Just y. So I'm going to divide everything by 3. Okay, everything's going to be divided by 3. And so now I see here that y is equal to kx over 3 minus 4/3. So that is my first equation. All right, let me do the same thing to the second equation. So I'm going to add 5y on both sides. Okay. I'm going to get 5y, I'm going to write it here, 5y plus 7 is equal to 4x. Subtract 7 on both sides. 5y is then equal to 4x minus 7. And then I'm going to divide everything by 5 to isolate y. This cancels out. And so then here I have y is equal to 4/5 x minus 7/5. So really all we care about is that the slope of this must be equal to the slope of this. Okay, and we know that y equals mx plus b, where m is the slope. Okay, So now all we have to do is set k over 3 equal to 4/5 because we know the slopes are equal to each other. And how do we solve fractional algebra problems? Okay, we cross multiply. Cross multiply. That was a bad bubble. Okay. And so we see that 5k is equal to 12. So k must be equal to 12/5. Okay, divided 5 by both sides. All right. So far, so good. Number 10. In the xy plane, the parabola with the equation y equals x minus 11 squared intersects with the line with the equation y equals 25 at 2 points, A and B. What is the length of AB? So basically, if I was just to kind of draw this randomly, right, here's my xy plane. Y equals 25 is a horizontal line at 25. And then we have some sort of parabola that looks like this. And so we see that it has 2 points that intersect. We want to see what is the distance between these 2 points. And so that is a really bad drawing for a pretty good problem. So you'll have to excuse me. So how do we see where these two lines intersect with each other? Well, we see that y is equal to 25 and y is equal to this little equation here. So what we can do is we can set the y's equal to each other, right? Because we want to see where they intersect. So let's set these equal to each other. 25 is equal to x minus 11 squared. So just like any other algebra problem, all we do is the opposite to both sides. So what is the opposite of squaring? Square rooting. Okay, so we want to square root both sides. What is the square root of x minus 11 squared? Right, and so the trick is with square roots, if you square root a square, they kind of cancel each other out, right? So we can ignore this altogether. And so that just becomes x minus 11. And what is the square root of 25? So you're like, oh, that's easy, it's 5. But I want you to be very careful here, right? It's not just 5, but it's also, it's also negative 5, okay? Because negative 5 times itself is positive 25. So in this case, there are two solutions, okay? One of them is equal to 5, one of them is equal to negative 5. So let's solve for x in both cases. So in this case, x is going to be equal to 5 plus 11, which is 16. And in this case, it's going to be negative 5 plus 11, which is 6. And so now we know that these 2 points are located at x is 16 and x is equal to 6. So what is the distance between those 2 points? That's going to be equal to 10. Between 6 and 16 will be 10. Alrighty. Almost done with the short answer, or the multiple choice portion. In the figure above, lines K, L, and M intersect at a point. If x plus y is equal to u plus w, so if this is equal to that, okay, which of the following must be true? 1, x is equal to z, okay, x equal to z, y is equal to w, and z is equal to t, and z is equal to t. Okay, so what do we know so far? Well, we know that this is equal to 180, and this is equal to 180. Oops, is that delayed? Yeah. Okay, so if that's the case, right, if these two angles are equal to each other, so the one going between y, w and u, and between x and y, then we know that these two must be equal to each other, right? We know that, because this is 180 and this is 180. So if you take out this portion and take out this portion, which are equal portions, then whatever's remaining must be equal as well. So we know that this is equal for sure. So we can knock out this, okay? Okay, so we only knocked out one. So now we have to see, is x equal to z, right? X is equal to z, okay? And is y equal to W. Alrighty. So y, actually, I do not see would be equal to W. All right, because we know that y is equal to u because they're opposite. Okay, so they're not they're vertical angles, right? This line and this line intersect each other, so we know that u is equal to w, and so that since these two are equal, y is not going to be equal to w because w and u are not equal, or at least we don't know that. So we can knock out 2 here. So we know this is not true. Oh, so that helps us a lot because now we know that B is not it and D is not it. All right, so B is our correct answer. Very nice. So we can move on to number 12. Alrighty, in the quadratic equation above, A is a non-zero constant. The graph of the equation in the xy plane is a parabola with vertex CD. Which of the following is equal to D? Okay, so we need to basically find out what is the vertex. What is the vertex CD? All right, so the very first thing we need to do is you probably, the way that you find out a vertex is if you have standard form, right? You have a standard form of a parabola as such, okay? Your x value of your parabola, okay? Your x value of the parabola is going to be, or sorry, your x value of the vertex is going to be negative b over 2a. All right, and this is actually a really good flashcard to have. So the x value of the vertex is going to be equal to negative b over 2a. All right, and this a is just purely coincidental. All right, so let us first solve out this by foiling, okay, and then we'll distribute the a in a little bit. So how do we FOIL x minus 2 times x plus 4? Well, the first thing in our FOIL, F-O-I-L, okay, and we're trying to FOIL this right here. So F means first times first, and so that's going to be equal to x squared. Outer means outer times outer, which is 4x. Inner means inner times inner. Okay, so that's going to be negative 2x. And last means last times last. So that's going to be equal to negative 8. So if I combine these, I'm going to have x squared plus 2x, right? Because I'm adding 4x minus 2x. And then I'm going to add negative 8 at the end. Okay, and don't forget that a is still multiplying by all of this, right? A is still multiplying by these. And so now if we distribute a, we get ax squared plus 2ax minus 8a. Okay, so far so good. So now all we have to do, we have to find out what negative b over 2a is, right? We want to find out what negative this over 2 of this is. Okay, and so what we want to do, and I'll put it maybe right here, we're going to do negative 2a over 2a. All right, following me, right? Negative b over 2a. And so a over a cancels out, and negative 2 divided by 2 is equal to negative 1. All right, so far so good. Wait a minute. Plus 2x. Okay. I think this is good so far. I have different things in my notes here, but I think negative b over negative 2a. Okay, and so if we know that the x value, right, so the x value of our vertex is negative 1, how do we find out what the y value is? Okay, and what you would do is you'd plug in negative 1 for x. So I'm going to replace negative 1 here, so that's going to be negative 1 squared plus plus 2a times negative 1 minus 8a. And so this becomes a minus 2a minus 8a. Okay, and so this becomes a minus 2a is negative a minus 8a, which is equal to negative 9a, which is a. All right, so I think that's correct. If I solve this incorrectly, I will put some sort of overlay or some sort of caption to see where my mistake was. Because, yeah, this looks pretty good. All right, so let me know if I'm wrong. Nobody's perfect. All right, you have to throw me a bone here. All right, moving on. Number 13. Oops. The equation, this whole mess, is true for all values if x is not equal to 2a, where a is a constant. Whew, what is the value of a? Okay, so how do we solve these complex fraction, messy problems? Well, what you want to do is you want to multiply everything by the least common denominator. Okay, and so that's a really good way to get rid of any denominator you want. So what is the least common denominator in our case? Well, luckily, it's pretty easy, right? Because ax minus 2 is the same denominator as right here, ax minus 2. So we know that ax minus 2 is common to both of these. Okay? So what we want to do, and it's going to look weird, but we want to multiply the entire equation by ax minus 2. All right, so that means multiplying this, and multiplying this by ax minus 2. But it's easier than it sounds. Why? Because in this case, ax minus 2 and ax minus 2 cancel out. So all that's left is 24x squared plus 25x minus 47, okay, is equal to, and then we have to multiply negative 8x minus 3 times ax minus 2, okay, and then here ax minus 2 cancels out as well. So all we have is minus 53 at the end. Okay, so let us FOIL this thing out first. So how do we FOIL this? First times first. Negative 8x times ax is negative 8ax squared. Okay, so that's first times first. Outer, negative 8x times minus 2, so plus 16x. Inner is minus 3x. Wait, inner is, sorry, minus 3ax. Last is minus 3 times minus 2, which is positive 6. Okay, and then we're subtracting this minus 53. Okay, and here it's still equal to whatever that guy is. But what's cool is that these two equations are equal to each other. All right, and so if that's the case, we see that negative 8a must be equal to 24, right? Because the leading coefficient of x squared will always be equal on both sides if the equations are equal to each other, okay? So we know for a fact that negative 8, and I'm sorry, and this is true also because plus 6 minus 53 is equal to minus 47, right? So minus 47 matches up here, right? This whole jumble in the middle will match up with 25x, and negative 8ax squared will match up with 24x squared. So we know that negative 8a is equal to 24. And if that's the case, we can divide negative 8 on both sides. Okay, and a must be equal to negative 3. So far, so good. Alrighty, so that is B. Okay, number 14. What are the solutions to 3x squared plus 12x plus 6 equals to 0? Well, that's pretty easy. And the answers kind of give you a hint as to what they're trying to urge you to do, and that is use the quadratic formula. And by this time, you should either A, have the quadratic formula memorized, or B, have it on a flashcard so that you're trying to memorize it every single day. Because this is a crucial formula to know coming into the SATs. So what is the quadratic formula? It is negative b plus or minus the square root of b squared minus 4ac all over 2a is equal to 0. Okay, so this is equal to 0, so we can now just easily extrapolate b, a, and c. So negative 12 plus or minus the square root of 144, my 4's are so terrible, minus 4ac. So 4 times 3 times 6. So 4 times 3 is 12, times 6 is 72, all over 2 times 3, which is 6. All right, so let me simplify the square root. So 144 minus 72 is 72. So in this case, I want you to see how can you simplify square roots. How can you simplify square roots? And this is another one of those core math techniques that you should be familiar with and comfortable with coming into the test. And so my favorite way of doing this is thinking about what is the greatest square root that can go into this number. Or sorry, what is the greatest perfect square, right? So what are some perfect squares? 4, okay, 4 can divide into 72 for sure. All right, what about any other square roots? Can 16 go into it? Can 16 go into it? No, I believe not. Okay, can 25 go into it? No. 36, can 36 go into 72? Absolutely. So we see that we can break this down into the square root of 36 times the square root of 2. This times this will equal to the square root of 72. And so how does this help us? Well, we know the square root of 36 is equal to 6. Okay, so 6 times the square root of 2 will be equal to 6 root 2. So now we can rewrite this as negative 12 plus or minus 6 root 2 all over 6. And in this case, both negative 12 and 6 root 2 are divisible by 6. So if we divide these now, we get negative 12 divided by 6 is negative 2 plus or minus 6 divided by 6 is 1. So we could just write this as negative 2 plus or minus the square root of 2. So I might have gotten a little bit too fast there. If I did, please let me know in the comments, and maybe I can make a separate little mini video kind of slowing that one down. Okay, 15. C is equal to 5/9 F minus 32. All right, this is a pretty familiar formula, converting Fahrenheit into Celsius. Fahrenheit relates to blah, blah, blah. We know that. Based on the equation, which of the following must be true? A temperature increase of 1 degree Fahrenheit is equivalent to a temperature increase of 5/9 degree Celsius. So is that true? Well, let's think about it, right? If let's say F is 33, okay, then we would see 33 minus 32 is 1, and that would be 5/9, right? C would be 5/9. What if F was 34? 34 minus 32 would be 2, and so 2 times 5/9 would be 10/9. So for every temperature increase, for every degree Fahrenheit, C also goes up by 5/9. Okay, and you could test that out yourself, right? You could just try out a few numbers that are consecutive and see if it increases by that amount. Okay, so 1 is definitely true. So we know that B is out, C is out. Okay, so all we have to do is check for 2. A temperature increase of 1 degree Celsius is equivalent to a temperature increase of 1.8 degrees Fahrenheit. So let's see here. What happens if you increase by 1 degree Celsius? Right? If you increase by 1 degree Celsius, so instead of C being 1, right, C becomes 2. What happens to F? Well, I see in this case, C is equal to 5/9 F times F minus 32. If I was to bring this 5/9 to this side, okay, I would see that I would multiply both sides, or sorry, I would divide both sides by 5/9, right? We want to do the opposite to both sides. So let me rewrite that here. C is equal to 5/9 f minus 32. If I was to divide both of these by 5/9, this would cancel out. And what is C divided by 5/9? What is that? Well, we know that dividing by a fraction, you want to keep, change, flip. So we want to keep this, we want to change division to multiplication, and we want to flip this to 9/5. And C times 9/5 is 9/5 C. So that would be equal to f minus 32. And so I see here that every time I increase C by 1, right, f should increase 9.9/5 times as fast. 9/5, because if I go C is 1, I would multiply by 9/5. If C is 2, it would be 18/5, right? So every time I increase by 1, f on the other side increases by 9/5. And 9/5 is equal to 1.8. That's why they chose 1.8 here. So we know that 2 is also correct. Bam. So D is our correct answer. And we don't have to even read 3. All right. So now we're in the short answer portion. At this point, I'm going to take like a 5-minute break. And I'm going to come back with a vengeance. And we're going to run through these short answer problems. There's only, I believe, 5 of them, if I'm not mistaken. Oh no, I'm lagging. All right. Is it coming back? Is it coming back? Or am I in forever lag mode? Please. I didn't mean to do it. Come back. All right. Well, in either case, I'm going to... All right, we're back. I'm going to let it do its kind of lag thing. I'll be back in 5 whole minutes. And maybe I'll put up a little timer here just so you know I ain't lying. It's going to be 5 minutes. Set timer for 5 minutes. Okay, and then I'm going to add a timer window. Alrighty, so I'll be back when that hits 0. Talk to you then. Alrighty, and we're back. So before I get to this short answer portion, just a reminder that we're trying to get to 20 subs for this first month of streaming, and I want to see if you're interested in the SAT. You don't have to be. You could be deciding between SATs and ACTs, and if that's the case, let me know in the comments, and I can maybe make some ACT videos and streams as well. And note that when we hit 20 subs, we're also going to be doing random sub Q&As. So what that means is on a random day, not the usual streaming days, I'll come on for maybe 1 or 2 hours. And if you're a sub, then you'll get a notification or an email, or you'll know right when I'm on, and you can come in for kind of like a smaller, more intimate question and answer portion. You can pretty much ask questions about anything related to middle school or high school math. So the only way you'll know about that is by hitting the subscribe button. So it'd be awesome. Hopefully you can get to 20 subs by July 31st, 2017, if you're watching this sometime later. Okay, but for now, let's continue with number 16 in the short answer. And this should be pretty easy, right? In the beginning of the short answers are usually pretty easy questions. So if x is greater than 0, what is one possible solution to the equation above? Okay, so maybe the first thing we could do is distribute x cubed to both of these. So x cubed times x squared is equal to x to the 5th minus 5x cubed is equal to negative 4x. So initially, actually, when I saw this problem, I plugged in 0. I'm like, oh yeah, 0 minus 0 is equal to 0. And it was correct, but then I saw that it said x is greater than 0. So I'd actually be really, really careful about this when you're taking it. Make sure that you are within the bounds that the problem asks you. So in this case, 0 minus 0 is equal to 0 doesn't work. But if you try 1, okay, and in this first problem of the short answer, they're probably not going to have you do anything too complicated, like solving for 5th root or 5 to the 5th power equations, right? So if we just plug in 1, we see that 1 to the 5th minus 5 times 1 cubed is equal to negative 4. Oops. Negative 4 times 1. Okay, and so 1 to any power will still be 1. So 1 minus 5 is equal to negative 4, and we know that. Okay, so 1 in our case is the answer. Alrighty, if 7/9 x minus 4/9 x is equal to 1/4 plus 5/12, what is the value of x? Alrighty. So we probably want to combine both sides into a single fraction each. And once we have that, we can use cross multiplication like we've done already twice on this test to solve for x. So let's see. 7/9 minus 4/9 is equal to 3/9. Okay, x is equal to 1/4 plus 5/12. Well, how do you combine fractions with different denominators? You probably want to have a common denominator, which in this case is 12. So we can change 1/4 into 3/12. Okay, and 3/12 plus 5/12 is equal to 8/12. Okay, and so now we have 3/9 x is equal to 8/12. So how do you cross multiply this, right? Where do you use x? Is it going to be on the top or on the bottom? And so in the case of 3/9 x, all right, we can rewrite this as 3x over 9 is equal to 8/12. All right, so this is how you would rewrite 3/9 x, just like this. And so now we just cross multiply. So 8 times 9 is 72. Is equal to 3x times 12, which is 36x, and divide 36 on both sides. So x is equal to 2. And I believe that is the right answer. Yes, it is. Sweet. All right, number 18. Two isosceles triangles are shown above, and these are not drawn to scale. Note that if it does not say this note, then it usually is drawn to scale. Two isosceles triangles are shown above. If 180 minus z is 2y and y is 75, what is the value of x? So in this case, they tell you what y is, and then we could use that to solve for z. And once you know what z is, we'll know what these two guys are, right? Because it's an isosceles triangle. And once we know what this guy is, we can then find the supplementary angle there. So that's going to be the strategy. Let's put this into action. So 180 minus z is equal to 2 times 75, right? 2 times y, which is 75. And 2 times 75 is 150. So now that we have 180 minus z is equal to 150, well, 180 minus what is equal to 150? We know that z is equal to 30, okay? So z is equal to 30. If z is equal to 30, then what are these two angles equal? Well, if z is equal to 130, then we know that these two angles combined must be 150, okay? Because all three angles of a triangle equal 180. So we know that these two combined must be 150, and in an isosceles triangle, these two are equal to each other, okay? The base angles are equal to each other. So that means that each of these, okay, is equal to 75 degrees. So this right here is equal to 75 degrees. And if this is equal to 75 degrees, 75 plus whatever x is has to be equal to 180, right? These are supplementary angles. So this has to be 180, okay? And so does this right here. And if that's the case, then 180 minus 75 is equal to, oh wait, let me write that, is equal to 105 degrees, okay? So x is equal to 105. Oh man, only 2 more problems? That's it. Let's do it. Number 19, at a lunch stand, each hamburger has 50 more calories than each order of fries. If 2 hamburgers and 3 orders of fries have a total of 1,700 calories, how many calories does a burger have? So this is an incredibly famous type of problem. I've probably seen at least 1 to 2 of these in every single practice test that I've done so far. So it might be wise for you to kind of, I'm not going to use the word memorize, but at least understand the technique of how to solve it. Okay? So this is a system of equations. We have the number of calories. So H is equal to number of calories in burger, hamburger, and F is equal to number of calories, oh my god, why do I keep doing that, in fries. And so we have 2 equations here. Okay, the first equation relates how many calories they have compared to each other. So it says that each hamburger has 50 more calories than each order of fries. So we knew that H is equal to however many calories F has plus 50. Okay, we know that. So that's our first equation. Our second equation is 2 hamburgers and 3 orders of fries have a total of 1,700 calories. So how do we write that equation? So that's simply 2H plus 3F is equal to 1,700. And with a system of equations, if you have 2 variables and you have 2 equations, then that's enough for you to solve for both variables. So in this case, we're going to use the substitution method. This is actually exciting. Earlier in this test, we did the elimination method, and now we're going to use substitution. So how do you substitution? We see that in this first equation, H is equal to F plus 50. So we know that this H is also going to be equal to F plus 50, right? Because the number of calories in the burgers don't change. So this H and this H are exactly the same. So what we can do is we can rewrite the second equation and substitute H for F plus 50. And you might be thinking, okay, why'd I do that? What was the point of that? Well, solving for 2 variables is pretty tough, right? We don't know how to do that. But if you have one variable and one equation, we do know how to do that, right? It's simple linear algebra. So you should be pretty familiar at this point. So we'll distribute, okay, the 2. So 2f plus 100 plus 3f is equal to 1700. We're going to combine these like terms. So 5f plus 100 is equal to 1700. We want to isolate 5f first, so we'll subtract. We'll do the opposite to both sides. 5f is equal to 1600. And now we're going to divide both sides by 5. Bam. And so what is 1600 divided by 5? I'll do my favorite dividing method here. So 5 goes into 16 3 times. 1 is left over, so I put a 1 next door. 5 goes into 10 twice. 0 is left over. 5 goes into 0 0 times. So 320 calories in fries. So we know that H is 50 more than that. So H is going to be equal to 320 plus 50, or 370 degrees. Very nice. All right, so we're almost done. Let's do this. Last problem. In triangle ABC, the measure of angle B is 90 degrees. BC is equal to 16 and AC is equal to 20. Okay. Triangle DEF is similar to triangle ABC. So before I go too much further, let me just draw how I think ABC is supposed to look like. So it'll be like this, that'll be like that, and that'll be like something like that. Okay. And so now this right here, so this is A, B, C. Okay, and we see that BC is 16, AC is 20. Okay, and so DEF is just going to be a smaller version of that. Okay, DEF. Okay, and so every side of this is 1/3 the size of the other one. What they're asking us is, what is sine of F? What is sine of F? Well, we know sine of F is going to be, right, so this is where you need to know your SOHCAHTOA, basic trig. Okay, and so means that sine is equal to opposite over hypotenuse. Opposite over hypotenuse. So it's going to be this. It's going to be this divided by this. The DE divided by DF. Opposite over hypotenuse. Okay. So yeah, maybe we should find out what AB is equal to, right? Because that's going to be compared to DE here. So how do we find out what AB is? Well, we know Pythagorean theorem, right? We know that for any right triangle, a squared plus b squared is equal to c squared. So we know that ab squared, so we'll put this to x, we know that x squared plus 16 squared, and 16 squared I believe is 256, is equal to 20 squared, which is 400. And so now if we subtract 256 on both sides, x squared is equal to 144. So x must be equal to 12. So this we know is 12. Okay? But what's interesting here is that sine, for any similar triangles, it's not going to change, right? It doesn't matter how large or how small this triangle is. Sine of this C will be equal to sine of this F, okay? Because sine only cares about the ratio between those two sides. It doesn't care about what the actual length is, right? If this is 12 and this is 20, it doesn't matter if this is 24 and this is 40, okay? As long as the ratio is the same, the sine is going to be the same. So we actually can kind of ignore this triangle in general. So what is sine of C? Sine of C is going to be 12 over 20. And how do you simplify 12 over 20? Divide both by 4. So that will be 3/5. So sine of f is going to be equal to sine of c, and that's going to be equal to 3/5. All right, so that brings us to the end of practice test 3, the non-calculator portion. So that's section 3 of practice test 3. If you have any questions, please let me know in the comments or in the chat. And I will be streaming again, hopefully, if all goes well, this Sunday at 7 p.m. The stream schedule is Sundays, Tuesdays, Thursdays from 7 p.m. to 9 p.m. if it goes that late. And like I mentioned, I'm not 100% set on SATs. If there's another topic where there's a really high demand and I feel comfortable teaching that, then I might switch topics. But for now, we're going to be continuing through these SAT Blue Book questions. And hopefully you're following along with me by clicking the link in the description, which has all of the College Board tests for free. And then, yeah, my last recommendation, as I said, is if you subscribe, I will be doing random subscriber Q&A sessions. They're not going to be posted. I'll just kind of turn on the stream, and if you're a subscriber, you'll get an email about that. So it might be worth it for you guys. Hopefully we'll hit 20 by July 31st, but if not, we're going to still keep on going, okay? Not too much pressure. So thanks so much for tuning in, and hopefully I will see you in the next session. Peace out.